Hello, everyone. I'm going to give a brief update on our current technical contributions over the past quarter. Some of the highlights that I'll be discussing are the main packages that we've been focused on here related to project work, YAC, which is TSDF for 3D reconstruction. No Ether is what we're using for toolpath generation on from point clouds. Tesseract and TrajOpt for motion planning, along with Descartes Light and OPW kinematics. And then I'll have a video of one of our systems that is currently in production using several of these packages for a scan and plan type system. And then I'm going to follow up with learning ROS-I and our upcoming advanced training, give some background on that. So most of our focus, previously mentioned, was focused, a lot of our projects here, I guess we got 3 or 4 different projects that are around this whole scan and plan concept. So most of our work has been focused on those packages supporting those type of integrations. Over the past quarter, the main improvement that was done to YAC is we went through and made it ROS agnostic. So we leveraged modern CMake to do that, along with recently upgrading to a newer version. It looks like some of the newer versions of CMake have better support for CUDA, which made things a lot easier compared to older versions. Most of that work's been done by Joseph Shornack on that. And he's also leveraging this both in ROS-I and ROS-II now, was the big motivation about making it ROS agnostic.
I think another thing to point out is if anyone made our Automate demo or saw some of the work out of the Automate demo, that was obviously as well, YAC was utilized for that Automate demo back around the member meeting as well. And that was in ROS, that portion was in ROS-II.
Yes. So No Ether is a package out there that we use for generating toolpaths, as you can see, from a mesh. A lot of work has been done on this package to improve its performance. All the waypoints on this have the z-axis pointing normal to the surface. And the nice thing is it can be divided into multiple sub-meshes based on, say, I think it has a few control parameters that you can adjust, like normal direction or curvature to say segment the mesh and generate toolpath specific to each of those individual meshes. Some of the other features that have been also added to this is, like, in some of these cases, you want to go off of the mesh in some processes, so there's utilities to allow you to do that, to extend toolpaths off the mesh to allow that, and also add extra what we're calling raster strokes also off the mesh too. This is something new we've been working on, leveraging SCXML, which is I believe it's a standard available for state machine definitions. We've been using this. The nice thing is that it can be used in Qt for managing the state of your GUI, but it can also be used outside of Qt for just, say, managing a finite state machine of your actual system. So it has nice features because it can be used in both cases, that it doesn't have to be used with the Qt GUI. The picture on the right is an interface that is directly supported by Qt for graphically building out your state machine and seeing the flow and testing your state machine. So we've been developing tools around this that allow support for ROS and just utility type functions that make it easy. One of those is attaching custom C++ function callbacks to state events in your SCXML type state machine. It's currently in work. We're using it on several systems right now, fleshing out some of the things on it, but the plan is to eventually open source this. Most of the SCXML or the QTS CXML is already available. You can start using it the main things that we'll be open sourcing are utility functions around that to make it easier to integrate ROS systems with this platform.
Cool.
Another thing that we've been focused on is Tesseract. The main things that have changed here recently is we developed our Tesseract geometry shape, mainly to support some current shape types that aren't currently supported within ROS. Around that, most of these are actually needed for TrajOpt because it expects collision geometry shapes to be convex hulls. So we've created a geometry library around it to add additional shapes like capsule, convex mesh. SDF mesh is mainly supported by Bullet. It allows it's a different type of collision shape that can handle detailed meshes, but also provide additional information like how to get two objects out of shape or out of collision by leveraging a mesh style sign distance field. And mesh parsers for parsing into these different types of shapes to control the convexity of each of them. And to support these new shapes, we've created a new URDF parser that not only supports these new shapes, but also has the ability to define quaternions for the rotational components of your origin. And then we've been focusing on the motion planning. We have OMPL fully integrated into the motion planners, and we've also created hybrid planners that say leverage for Cartesian toolpath generation, leveraging Descartes plus TrajOpt to handle more complex constraints and costs. And then for free space motion, we leverage OMPL plus TrajOpt. And then on top of this, we've been generating what we're calling process planners. Most of this is around the scan and plan process using NoEther, where you get a toolpath that is generated on the tool surface, but that may not be the right toolpath for your process. You may want to, say, for grinding, you may want to angle the disk at some angle as it's riding on this surface. So this is more of a framework that allows you to define your process such that it takes that toolpath generated by NoEther and modifies it to meet your process needs. And then it sends that to, say, these hybrid planners for optimization. Get it right in time. And then there's been ROS2 support on this. There's currently, I think the only thing that has not been ported at the moment is the RViz component of it. I believe all the environment monitoring and everything else, I think that's just a major piece of it. So for TrajOpt, there hasn't been a whole lot of work here. There's been more just evaluating how we can improve this. The only new thing that's been improved is where you have dynamic Cartesian costs and constraints, where you have, say, two robots wanting to interact with each other. How do you leverage TrajOpt to do that? We also evaluated low-level data structures to replace the current data structure that is being used in TrajOpt. We've more or less settled on IFOPT and eigen autodiff, but we'll have to plan out when that's going to happen. And one of the next steps is try to remove the dependency from TrajOpt on Tesseract to allow this to be this motion planner to be used outside of Tesseract, to be used, say, by MoveIt or Drake or one of those other motion planning libraries. Our plan is to leverage type erasers to do this. Descartes and OPW kinematics, the main things that's been done on here is creating user-friendly interfaces for IK-fast and gantry system samplings, and also making both OPW and Descartes Lite ROS agnostic to be used in both our ROS1 and ROS2 systems. And hopefully this works. So I couldn't get the video to turn. I guess in Linux you can't rotate videos, but this is one of our systems that is leveraging all these different libraries to do a scan and plan type process, where we've we've scanned a part in a gantry cell, reconstructed the surface, used NoEther to generate toolpath on that surface, and then leveraging Descartes and hybrid planner Descartes plus TrajOpt to solve the robot trajectory. In this, it was actually a very challenging issue because, as you can see, the end effector and all the cables and stuff, there was a lot of very unique costing constraints that really restricted the configuration space of this robot. We have some ideas that it'd be nice to update, I guess, the URDF to handle some of these things that are easily done on industrial manipulators, where they're able to use, like, I guess on Fennec, they can use DCS constraints to limit joint regions based on other joint values and those type of things. So we've come up with a pretty good way of handling that in TrajOpt by defining those constraints. Our next step is to figure out how or where we should put those. Should those be integrated into the URDF or, say, SDF, things like that. Let's see if it'll let me.
Did you just kill your deck?
Yeah. Well, yeah, it won't. For some reason, it won't let me stop the video.
Can you just go to the next slide?
I think, Windows. There we go. No. The only other slide I had after this was the ROS-II thing. So if it'll let me go to the next slide. Come on. There we go. So the next thing, learning ROS-II. It looks like we've, as part of a client project, we've ported over 71 packages from ROS-I to ROS-II. Most of that work was started with Crystal and then later migrated to dashing. These are just some of the highlights that were from that migration. The overall experience, it was one of our main developers. This was significantly harder than ROS-I, and it's underdocumented. So there's a lot of time spent digging around in the API to figure out how best to do things. One of the pros to it is it's working in stable, in dashing, no more random crashes. And some of the main changes he highlighted on was nodes don't necessarily equal processes, because it now supports like components in that sense. Parameters are now local to each of the nodes, and there's a maximum string length of 256 characters on strings, which has caused some limitation issues with, say, loading a URDF into a parameter or a SDF or SRDF into parameters. So most of them are switching over to storing file paths in that sense. Also, there's no global parameters at the moment. Everything is specific to a node. And one other highlight was that callbacks executions, the asynchronous behavior is a responsibility of the developer now on that, so things like that. We have an advanced training where there'll be a lot more detail on a lot of these different components that will be part of the ROS Industrial training coming up in October, early October?
October 8th.
October 8th. So there'll be a lot more information on each of these different components and how to address those, or how we address those in our migration process.